So we'll start with triple angle formula. So we have three triple angle formula. Sine 3 theta is 3 sine theta minus 4 sine cube theta. Second, cos 3 theta is 4 cos cube theta minus 3 cos theta. And then tan 3 theta is 3 tan theta minus tan cube theta upon 1 minus 3 tan square theta. Remember these formulas. If you want to prove it, I can prove. Let me prove one of these three. So let me prove first one. That is not needed, but still I prove one. See, sine 3 theta. Sine 3 theta. You can write this as 2 theta plus theta. Now treat this as sine of A plus B. And you know the formula of sine A plus B? What is this sine? Do you remember the formula? Sine of A plus B?
Sin A cos B plus cos A sin B.
No, I know. I'm asking Shaina and Parthiv.
Oh, sorry, I didn't hear you, sir. So,
Can you tell me the formula of sine of A plus B?
yeah. Sin A cos A plus cos A sin B.
Parthiv, do you remember? Parthiv and Shaina, can't you enable your video? If possible, then you can enable. Na?
Okay, sir.
Shaina, you too. It feels good, like direct interaction. So this is sine A cos B plus cos A sin B. So we'll apply this formula here. Sine A cos B plus cos A sin B. Now, you know the formula of sine 2 theta. That is 2 sin theta cos theta into this cos theta. And you also know cos 2 theta. What is it? What is that? 1 minus 2 sin square theta into sin theta. See, this is 2 sin theta and this is cos square theta. You can use the identity. Sin square theta plus cos square theta is 1. So cos square theta will be 1 minus sin square theta plus 1 minus 2 sin square theta and sin theta. Open it. 2 sin theta minus 2 sin cube theta plus sin theta minus 2 sin cube theta. Add it. 2 sin theta plus 1 sin theta. That is 3 sin theta minus 2 twice. That is 4 sin cube theta. Like that, you can prove all cos 3 theta and tan 3 theta. Write one proof, and based on that, you can prove yourself. From next week, now we'll have test as well. I'm just waiting for Archit. He will come. Then every Sunday we'll have test.
Sir, just a
Whatever I
minute.
teach,
So Sunday or Monday?
every Sunday. So what time? Sunday you are not free?
No, I was just checking, sir, which day.
So Sunday, every Sunday, like whatever I teach throughout the week, I will take test on Sunday.
Okay.
Shaina, note it down the first proof. Done? Noted? Sana, you noted?
Done, sir.
Parthiv, you are done?
No, sir.
Parthiv, you are from which place?
Sir, Maharashtra.
As a Maharashtra. Okay.
Yes.
Done?
Yes, sir.
Okay. Now we'll move to we'll learn some basic trigonometry graphs that are required, right, to move ahead. So you have to remember these graphs. These are the basic some important basic graphs. Based on this, we'll also study transformation of graphs. But before that, we have to learn these. First, y equal to sine x. Y equal to sine x. So its graph looks like it passes through origin like this, like sinusoidal curve, and like this, never ending curve. It keeps on going like a wave. The maximum value is 1 and the minimum value is -1. This graph is also known as bounded graph. Bounded graph. Bounded means it has a limit, upper limit and lower limit. It cannot go beyond these limits. Now you can see points where it cuts x-axis is known as roots of this any function, any curve which cuts x-axis. That point is known as roots of the equation or zeros of the equation. So we can see that this graph intersect at x-axis at here origin, at here, at here, 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 and like that. पार्थिव ये तुम बीच में कहीं चले जाते हो उठ के नहीं कहीं जाना नहीं क्लास छोड़ के ठीक है
Okay, sir.
ठीक है तो now we can see that at these points this sine curve intersect x-axis. It means that at these points the value of sine becomes 0 because we know that on x-axis y coordinate is 0. So at these points sine becomes 0 and these points are 0, pi, 2 pi, 3 pi, 4 pi, like that. And here on the left side, minus pi, minus 2 pi, minus 3 pi, minus 4 pi, and like that. So we can say that if sine x equal to 0, x can be n pi, where n is integer. Means you can take any value of n, like 0, 1, 2, 3, 4, minus 1, minus 2, minus 3. So sine pi is 0, sine 2 pi is 0, sine 3 pi is 0, sine 0 is 0, sine of minus pi is 0, like that. So when sine becomes 0, x can be any value. Integral multiple of pi. So we can write this as sine x is 0 for every integral multiple of pi. Now, you can also see that this is 1. So at this point, sine takes 1. So this is pi by 2. Again here it takes 1. Again here it will take 1. Again here it will take 1. Again here it will take 1. So this is pi by 2. Next one would be 3 pi by 2. So in the interval of pi by 2 plus pi, 3 pi by 2, and then again 3 pi by 2 plus pi. This will be 5 pi by 2. This will be 5 pi by 2 plus pi. 7 pi by 2. This will be 9 pi by 2, and like that, like here as well. This is minus pi by 2. This is minus 3 pi by 2, minus 5 pi by 2, and like that. So if I ask you, if sine x equal to 1, so x can be 4n plus 1 pi by 2. Put n equal to 0. N can be anything. Minus 3, minus 2, minus 1, 0, 1, 2, 3, etc. Any integer. Take n equal to 0. It will become 4 into 0 plus 1, 1 pi by 2. Sine pi by 2 is 1. Take n equal to 1. 4 into 1 plus 1, 5. 5 pi by 2. 5 pi by 2, sine is 1. So these are the important points that you need to remember. When sine x becomes 1 at every 4n plus 1 pi by 2 value. And third point is if sine x is minus 1. So you can see 3 pi by 2, 7 pi by 2, minus pi by 2, and like that. So x will take value 4n minus 1 pi by 2. N can be any integer. Put here and you can cross check. Note it down. These are the basic information about trigonometric curve. So you need to remember these things. Based on that, like it will help you a lot going forward in next chapter while solving the problem.
Done, sir.
Everyone done? Parthiv and Ayushi?
Yes, sir.
Yes, sir.
Now you can see there are two terms. First one is domain, and second thing is range. Range. Domain means all those values of x where any function exists. It means that function will be defined. Means function can give you some definite value. So all values of x are known as domain where function exists. Now you can see this sin x curve exists everywhere. For every value of x, it will give you some value between -1 to 1. So domain of this function is all real number. So x belongs to all real number. Domain of sin x is all real number. Range. Range means output. What value you get. So sin x takes maximum value as 1 and minimum value is -1. So range is -1 to 1, including -1 and +1. Sin x cannot go beyond these limits. So maximum value of sin x is 1 and minimum value is -1. Sin x can be like this, can be written like this. Sin x is, there is a term periodicity. Periodicity. I will talk much about this term in calculus, in function. But sin x is a periodic function. Sin x is a periodic function. What does this mean actually? Periodic function. Any function is known as periodic function if it repeats itself after a certain period. Like you can see, you can start from anywhere. You can start from origin. See, sin is stuck. This is writing. You can start from origin. See, from here you can see that. See, you go like this, like this, like this, like this. You reach here, right? Now, from here at this point, you can again see that it takes the same shape like it took here at this point. So in this interval, like at this interval, this graph, this shape, you can see this shape again appears from here to here, again from here to here, again from here to here. So after every 2 pi interval, its shape repeats, right? So the periodicity of this graph is known as is 2 pi. This is the called period of this graph. We represent it by capital T. Period of sin x. And you will call it fundamental period. Fundamental period. Means after this interval, this was interval, graph will repeat its shape. Noted? Done? Parthiv?
Sir, just a minute.
Hmm.
Done, sir.
Now, second point, y equal to cos x. Graph of cos x looks like it starts from here. Like this. Like this. Keeps on going. Like this. Like this. You can observe one thing. Sine started from origin. So at x equal to 0, sine x is 0, right? Sine 0 is 0. But at x equal to 0, cos takes value 1. So cos 0 is 1. Sine 0 is 0 and cos 0 is 1. So whenever sine becomes 0, cos becomes 1. And whenever cos becomes 0, sine becomes 1. And cos intersect the x-axis here at all in odd multiple of pi by 2. Pi by 2, 3 pi by 2. These are the basic information that you have to remember. 7 pi by 2 and like that. Minus pi by 2. Minus 3 pi by 2 and like that. Again, you can see there is no break in the graph. So, what I mean to function exists. What does this mean actually? Function exists means function will give you some value at some value of x, right? So suppose if I draw function like this. So there is a break, right? There is a break in the graph. So if you take this x, you'll get this value. If you take this x, you'll get this value. But if you take this x, there is nothing here. Because function does not exist here. You won't get any value. So I meant that actually. This function is not defined. So another term for this is continuous function. So if you draw the entire curve without lifting your pen, it means that function exists and function is continuous, right? So you can see here. So again, domain of cos x is all real value of x. For each value of x, sin x and cos x exist. So domain is all real value of x. And range is -1 to 1. Again, cos x lies between this range. So the maximum value of cos x is 1 and minimum value of cos x is -1. And
Sir, can you explain the undefined part again?
see, undefined means for certain value of x, function will not give you any value, right?
Yeah.
So it means that function is not continuous. It means that there is a break, there is a gap in the curve like this. Suppose I draw any curve like this, like this. So for this x, there is a curve here. You can get this value. For this x, you can get this value. But suppose between this range, between this interval, if you take this x at this value, there is no curve here. There is
Yeah.
a gap. It means that function does not exist for this interval.
Got it.
Now, remember these things. So at what points cos takes 0? So x equal to 2n
2
plus minus 1 pi by 2. It means for all odd multiple of pi by 2, cos x gives you 0 value. Cos pi by 2, cos 3 pi by 2, cos 5 pi by 2 and like that. At every odd multiple of pi by 2, cos x becomes 0. But sine becomes 0 at integral multiple of pi. 0, pi, 2 pi, 3 pi, 4 pi and like that. But cos becomes 0 at every odd multiple of pi. So 2n plus 1 is also odd and 2n minus 1 is also odd. So you can take any. And where n is integer value, it can take any value, positive, negative, any value, 0, anything. So you have to remember this thing. Second point that you have to remember is cos x is 1. For what values of x, cos takes value 1. So x will be even multiple of pi. Even a multiple of pi. That's why I have written x equal to 2n pi. Take n equal to 0. Cos 0, 1. See, this is 0. This is pi. This is 2 pi. This is 3 pi. This is 4 pi. This is minus pi. This is minus 2 pi. You can see that at every even multiple of pi, like 0, 2 pi, 4 pi, minus 2 pi, it takes value 1, right? And when cos takes minus value, x is odd multiple of pi. 2n plus 1 or 2n minus 1 pi, whatever you want to write, you can write. You can see cos pi minus 1, cos 3 pi minus 1, cos minus pi minus 1. Again, cos is a periodic function. You can see, you can start from anywhere. Suppose you want to start from here. You can see, come like this, see. It will come like this till here. From here, again, you can see, it takes the same shape like it took from here. And this shape, this, this shape keeps on repeating. You can see. You can see. So this is the interval. This is the least positive interval, 2 pi. At this interval, graph repeats its shape. So this is known as fundamental period, and we denote it by capital T. So cos x is also a periodic function, and its period is 2 pi. Period is 2 pi. I'll prove this in calculus, not here.
Sir, can you explain that again? The when cos is -1.
See, cos is minus 1. You can see that at this point, cos takes minus 1 value.
But
Again,
sir, for but it's the same value for cos x equals. Oh, okay, understood. Wait. So, but it's the same value for okay, that's pi by 2. Okay, got it.
that's pi by 2. This is pi
Yeah.
by 2. This is pi by 2.
Okay.
This is also known as bounded curve. Bounded curve. Because it cannot go beyond minus 1 and plus 1. This is bounded. Bounded, there are two types of curve, bounded and unbounded. So sine and cos are bounded curves. Parthiv, you're done?
Yes, sir. Yes, sir.
ठीक है. Third one is y equal to tan x. Now I have to draw the graph of tan x. Now you see, how will I draw? If I know cos and sin now, we can easily draw tan, cot, sec and cosec. But how? See, tan x can be written as sin x by cos x. Now we can see, first thing you have to observe that at what values of x, at what point this tan x is undefined. So tan x will be undefined whenever cos becomes 0, because cos is in denominator, and if denominator becomes 0, it will be undefined, isn't it? So now you have to check at what point cos becomes 0. Now you tell me cos becomes 0 at what all points? Do you know? Odd multiple of pi by 2, cos pi by 2, cos 3 pi by 2, cos minus pi by 2 and all, right? So cos becomes 0 at odd multiple of pi by 2. Like that is
90 degree.
Yes. Minus 3 pi by 2, minus pi by 2, plus pi by 2, 3 pi by 2 and like that. And now you can also observe one thing, where this tan will intersect x-axis. So whenever tan becomes 0, it means that this will intersect x-axis, right? So when tan will become 0, whenever sine becomes 0, because sine is in numerator. So whenever numerator takes 0 value, then the whole thing will become 0. So you can see sine x is 0, where all integral multiple of pi, that is minus 2 pi, minus pi, 0, pi, 2 pi, etc. like that. That's enough information for us. You can see. This is your x-axis. This is your y-axis. This is 0. See, this is pi by 2. This is 3 pi by 2. This is 5 pi by 2. This is 7 pi by 2. This is minus pi by 2. This is minus 3 pi by 2 and like that. Right now, I'm not going in depth because, I cannot make you understand the differentiation right now, right? I'm not discussing about the concavity of the curve. Concavity means like, the shape of the curve will be like this or like this. This is known as concave upward. This is known as concave downward. I'm not discussing at all these things right now. We'll discuss later. Now we know that at every integral multiple of pi, sine will be tan will be infinity because cos will become 0. So 0 in denominator will make it undefined. So infinity. It means that just draw. You can see that the graph will be like this, because at pi by 2 it is undefined. At pi by 2 it will go to plus infinity. At minus pi by 2 it will go to minus infinity, and at 0 sine becomes 0. So the whole thing will become 0. Hello. Yes, बोलिए. नहीं चाहिए मैम, थैंक यू. So, yeah. So now again at pi by 2 minus infinity, at pi sine becomes 0, so tan will become 0, and then like this. So the graph will be like this. Shape will be like this. Sorry. This is your 3 pi, like this. 3 pi by 2 at this minus 3 pi by 2, it goes to minus infinity. At minus pi, it takes 0 value, and again minus pi by 2 plus infinity, like this. Understood or not? Did you understand?
Yes, sir.
Yeah, you have to remember this. Note it down. Done, everyone? Now tell me domain. What is the domain? Domain, you know, all those values of x where function exists. Now, domain can be all real number, right? Domain can be all real number, isn't it? Are you see? Domain can be all
Yes,
real
sir.
number. Everywhere function is defined.
Yes, sir.
China, Parthiv,
Yeah.
Yes, sir.
no. This function is not defined at integral multiple of pi by 2. You can see that at pi by 2, it takes value infinity.
The
Minus pi by 2, it takes.
range is all real.
That is fine. I am not talking about range. I am talking about domain. Domain means you have to see all those values of x where function can give you finite value.
So at odd multiples, it's not defined.
It's not defined because it gives you infinity. Infinity is not a definite number. So at every integral multiple of pi, tan gives you infinity. Tan 90 degree infinity, tan 270 is infinity, like that, right? So domain would be r minus. All real numbers, you have to subtract a odd multiple of pi by 2 from r. Understood? So at every integral multiple of pi by 2, tan is undefined and that should be excluded from the domain. Undefined. Infinity, na? Infinity is not a definite number. It's not defined. And range would be what? Range means output.
All
What
real.
minimum or what maximum value you can get. All real number. All real number. Minus infinity. You can also write this like minus infinity to plus infinity. Any value to any value, right? Minus infinity to plus infinity. Now you can see, is this the correct way to write this interval? Is this the correct interval or not? Can I
No,
put
we have to
closed
put it in
interval?
circular brackets.
Yeah,
Right,
parenthesis.
right. Because infinity is not a definite number and we don't know what exactly it is. So we cannot include this. Capital bracket means including that thing. Smaller bracket means excluding that thing actually. Now, can you guys tell me what is the period of this function? Party, what do you understand by period? Interval after which the curve repeats itself. Now you can tell me at what interval the curve will repeat itself. You can see pi, na? You can start from anywhere. Start from here. Minus pi by 2 se start. Karo. Now you can see that from year to year, whatever shape you have, again you have the same shape, again you have the same shape. So at every interval of pi, the curve repeats itself. So this minus pi by 2, so length is pi by 2 and plus pi by 2. So the pi by 2 plus pi by 2, pi, na? Right? Understood, na? So period of sine and cos is 2 pi, but period of tan is pi only. Understood, Parthiv? China?
Yes, sir.
Note it down. Next graph I'll give you. You have to draw. I mean, just try.
Done, sir.
Parthiv, you also done? I see.
Yes.
Yes, sir.
ठीक है. Next function is y equal to cot x. You guys try. I'm giving you 5 minutes.
So I got,
You got?
yeah.
Can you send me on the group?
So be the opposite. So if the in the tan graph it's curving like the reverse S, in the curved little graph like an S.
Correct. Fine. Okay, let them do. Yes, I see. Yes. See, it is like cot is what? Cos x upon sin x opposite to tan. So now you can see that wherever sin will take 0 will be 0, cot will be undefined. And wherever cos will be 0, cot will be 0. Now you see sin becomes 0 at integral multiple of pi and cos becomes 0 at odd multiple of pi by 2. Zero, pi, 2 pi, minus pi, minus 2 pi. So at 0 and pi, cot will be undefined. So graph will be like this. Like this. Like this. It will keep on going. And where it intersect the x-axis, odd multiple of pi by 2, where cos becomes 0, and like that. So if you define domain, tell me, Parthiv, domain. Domain is all real number except beta and pi, because at 0, pi, 2 pi, it takes infinity plus infinity or minus infinity value, no? So that is not defined. So you can exclude that. And the range is all real number, yeah, minus infinity to plus infinity. And period is what? Again, like 10, that is pi only.
Sir, I didn't understand why the curve will get reversed.
That yeah, that is about the concavity of the curve that I told you now. We'll discuss in calculus, not here.
Okay, sir.
It will be bounced to all. So you must have understood, like cot becomes infinity at 0, pi, 2 pi. That is understood, na?
Yes, sir.
Okay, fine. Chalo. Done, everyone? Parthiv done. You also done?
Yes, sir.
Okay, fine. Fifth one is y equal to sec x. Sec x is what? 1 by cos, na? So wherever cos will be 0, sec will be undefined. So cos will be 0 at all integral, odd multiple of pi by 2. So at these odd multiple of pi by 2, sec will take infinity. So its curve will be like minus pi by 2 plus pi by 2, 3 pi by 2, 5 pi by 2, minus 3 pi by 2, and like that. See, you know that cos always lies between minus 1 to 1. So denominator is always in between minus 1 to 1. So if you divide 1 by any smaller value that lies between minus 1 to 1, you will get bigger value that is more than 1 or less than minus 1. So at 0, you can put cos 0 is 1, 1 by 1, 1. So sec is 1 at 1, at 0. And now it will go to infinity like this, ball shape. Because at 0, cos is 0, 1 by 0, 1, 1. At this point, at 2 pi, at pi, you can see cos pi is how much? Minus 1. Cos pi is minus 1. So 1 by minus 1, minus 1. So this is minus 1. So graph will start from here like this, down. And like this, you can repeat the curve like this. Understood? You just have to repeat this unit. This unit you have to repeat.
Sir, so what are unbounded graphs?
Unbounded. This is
Graph?
unbounded. This is unbounded. Tan cot was unbounded too. I forgot to write that. You can write.
Okay.
This is also unbounded. Unbounded matlab there is no limit. It can go up to plus infinity. It can go down to minus infinity. And domain you can say all real value except odd multiple of pi by 2 where it is undefined. Range you can see plus 1 to plus infinity and minus infinity to minus 1. Minus infinity to minus 1 and 1 to infinity. And you can see the period would be 2 pi again. Why? This unit, this length is pi by 2, this length is 3 pi by 2. So complete thing would be 2 pi. So after this, after every 2 pi, this will repeat its shape. You can see here. These are the basic things that you need to learn. You have to remember this. पार्थिव समझ में आ रहा है?
Yes, sir.
ऑनलाइन अच्छा लगता है पढ़ना है ऑफलाइन?
Sir, offline.
क्यों ऑनलाइन क्यों नहीं अच्छा लगता?
Sir, not that. Because I'm
क्या?
used to offline.
ओके तो मतलब तो फिर तो नहीं पढ़ना है ना ऑनलाइन फिर तो।
Sir, even online is comfortable.
कल पापा ने बोला था तो मैंने उनको यही बोला था कि लेट हिम अटेंड वन ऑनलाइन क्लास, देन यू कैन डिसाइड। तो ऑनलाइन और ऑफलाइन का भी अलग अलग अपना बेनिफिट होता है।
Yes, sir.
ठीक है, वो तुम्हारी मर्जी,
Yes, sir.
बट समझ में आ रहा है ना।
Yes, sir.
डन चाइना, चाइना डन,
Yeah, done, sir.
पार्थिव योर से डन।
Yes, sir.
ठीक है, ओके, लास्ट ग्राफ इज सिक्स्थ वन, y equal to cosec x. So you can write this cosec x as 1 upon sin x. Now you can see that wherever sin will become 0, this will be undefined because 1 by 1 upon 0. So cosec will be undefined. Now you know that sin x becomes 0 where? At every multiple of pi. Simple. It will be like this: 0, pi, 2 pi, 3 pi. This is minus pi, minus 2 pi. Now you can see that one thing. At 0 you can see 1 by sin 0. Sin 0 is 0 na, so 1 by 0 infinity. And at pi, so this graph will be like this. And you can see at here, this is pi by 2. So at pi by 2, sin pi by 2 is 1. So put here, so 1 by sin pi by 2, that is 1. So cosec will be 1. So the graph will be like this. At 3 pi by 2, what is the value of sin 3 pi by 2? Minus 1. Sin 3 pi by 2 is minus 1. So 1 by minus 1, minus 1. So this is minus 1. So graph will be like this. At every integral multiple of pi, it will be undefined. You just have to repeat this unit again and again. That's it. Very simple curve. Very simple curve, right? You have to remember all of this. Now I will ask you guys one by one. What is the domain of this curve? IUC?
R minus n pi.
Correct. R minus n pi. China, you understood?
Yeah, I got this.
Parthiv, you understood this? Parthiv,
Yes, sir.
tell me range, Parthiv. What is the range?
Sir, infinite.
State like minus infinity to plus infinity means all real number.
Yes, sir.
And what is the period? China.
So how is range all? It should be 1 to infinity and minus
Oh,
1 to
sorry,
nothing.
my bad. Sorry. Range would be again 1 to plus infinity and then minus infinity to minus 1. Correct. Very good, China. And what is the period, China?
Uh, I think pi, right?
No,
Pi.
2 pi, na?
No,
2 pi. See,
yes, yeah.
0 to 2, 0 to pi and pi to 2 pi. In this interval, in this complete interval, so this is pi plus pi 2 pi, na? This unit keeps on repeating, na? You can see,
Yeah, got it, sir.
right? So see, what is the period of sine? That is 2 pi, and cosec is what? 1 by sine, na? So 1 by or 1 into does not make any difference. So whatever will be the period of sine, the same will be the period of cosec as well.
Okay, got it, sir.
Parthiv, understanding na?
Yes, sir.
Hmm. Okay, now I'll ask you some questions. I'll give you some questions now. It's enough theory for today. See, here is the question. You can try. Giving you 2 minutes to everyone. Try.
So it should be C minus 2.
See, acha, okay. Any reason?
So because cos theta can only go until minus 1. So at most there's minus 1, which is minus 2.
But that another angle is 2 theta, na?
But
So,
still it's you still can't have beyond the theta, right?
oh, you're talking about a maximum value. The question is about minimum value.
Yeah, you still can't have below that.
Oh, what? No, no, no. No, it is not like that. See, remember one thing. Whenever you see different angles now in question, you cannot solve that. First of all, you have to make all the angles same. So see, this angle is double 2 theta, and this angle is single, like single theta. So first you make both the angles same. So you have to apply this formula. Cos 2 theta is 2 cos square theta minus 1, and then this is cos theta. So 2 cos square theta plus cos theta and minus 1. Understood? Now you can write a perfect square. So this is like take 2 common cos square theta plus half cos theta, and let it be like this one. So this is a square plus 2a and b. B you have to write 1 by 4. I hope like everyone must be knowing how to make perfect square. So you have to write 1 by 4 so that it will become cos theta by 2. And because you have added this thing now, so this would be, this is 2, this is a, this is b. So b square. And because you have added 1 by 16, so you have to balance it as well, like this. So now from here to here, it will give cos theta plus 1 by 4 whole square. And this 2 will multiply with this and it will become minus like this. So 2 cos theta plus 1 by 4 whole square minus 9 by 8. Now you can see the square of anything is always positive. Square of anything is always positive. The list value will be 0. So when this will become 0, so 2 into 0, 0 gone. So the list value will be minus 9 by 8. Understood? Always remember to make all the angles same. Then only you can solve the problem. Otherwise not.
So how did you write it as minus 1 by 8?
Where?
In the second to last equation.
Uh,
Cos theta plus 1 by 4 whole squared minus 1 by 8 minus 1. Below, yeah, that one.
this one.
Yes, sir.
See, from this is a square plus 2ab. This is b square. So a square plus 2ab plus b square. It will become a plus b ka whole square.
Yes, I got so, yeah.
And 2 multiplied to each term. So this will become minus 1 by 8.
Okay, okay. Understood.
Sir, I didn't get the last step.
Which one? This one. This one. Are you see?
Yes, yes, sir.
See, square of anything can always be greater than or equal to 0. It can't be negative. So this is square of something, na? So the minimum value of this term would be what? 0, na?
Yes, sir.
So you have to find minimum value. So put here minimum value 0. 0 into 2, 0 minus 9 by 8. So this thing will be always greater than equal to minus 9 by 8. So something if this is greater than or equal to always minus 9 by 8. So minimum value will be minus 9 by 8.
Okay, sir.
Done.
Done, sir.
Yes, sir.
Parthiv also done. Parthiv done, na? You're not done. Yeah.
Yes, sir. Done.
See, solve this one.
Sir, there shouldn't be any solutions
Why so?
because I don't think sin x and cos x can be 1 at the same time.
Yes, very good. You know that the maximum value of sine can be 1 and cos 1 will be 1. And this will become 2 only when this becomes 1 and this becomes 1. But that is not possible. Whenever sine becomes 1, cos becomes 0. Or cos becomes 1, sine becomes 0. So this is never possible. So the number of solution is 0. Understood? Good. Very good, Simon. This one. तुम्हें समझ में आ रहा है पार्थिव? Just apply the triple angle formula. Giving you 5 minutes. Solve it.
So I think I got it, but I'm not sure completely.
Okay, fine. Ayushi and Parthiv.
It's a proving question, so there's no answer, but like I think I've got it. I'm
So
not
can
sure.
you send me the solution?
Yeah, sir. But I'm not completely sure yet. I
No problem. Just send me. Let me see that. I'll solve it again. That's why it is good. It's too lengthy. Let me solve it. Let me solve it. Solve it.
the first part is wrong. I scratched it off later on, like the bottom part, the four
See.
line.
Okay, see. You are given this thing. So write the formula of tan 3a. What is this? 3 tan a minus tan cube a upon 1 minus 3 tan square a. This is the formula of tan 3a. 3 tan a minus tan cube a upon 1 minus 3 tan square a upon tan a. So here 1 by tan a equal to k. Now see, 1 tan will cancel each other. So this is 3 minus tan square a cross multiply. This is k minus 3k tan square a. Bring tan square a to one side. This is 3k minus 1 tan square a, and this is k minus 3. So you have tan square a as k minus 3 upon 3k minus 1. Now you have to find what? See, this thing. This thing you have to find now. So do one thing. Right here, sine 3a upon sine a. What is the formula of sine 3a? That is 3 sine a minus 4 sine cube a upon sine a. So one sine will get cancelled, minus 4 sine square a. So basically you have to find sine square a. Na? So how would you find that? Now see here. You can write tan a as sine a upon cos a. So tan square would be sine square a upon cos square a, k minus 3 upon 3k minus 1. Now see sine square a, but you want sine square a. Na? So write this cos square a as 1 minus sine square a. Write this cos square a as 1 minus sine square a. Very simple. Now you cross multiply it and get the value of this. Or you can say, you can apply component to dividendo. So like if I do sine square a and this plus this, denominator, you will get 1 because no 1 minus sine square a plus sine square a. Only dividendo I'll apply. So k minus 3 upon this plus above 1. 4k minus 4. So now you have sine square a as 1 by 4 out, k minus 3 upon k minus 1. See, eh? There is a mistake. There is some mistake. Check where it is. Tan 3a is 3 tan a minus tan cube a upon 1 minus 3 tan square a. This formula is right or not?
So how did you
Yeah.
get sine square a by 1?
Where?
In the red after the long equation.
Oh, okay. Wait. I have to put this value. I have to put this value here. Here. Because we have to find this value. Na? Okay, note it down. I thought I had to find sin square a only. Note it down. Did you understand what I did?
So how did you get sine square a by 1?
Oh, okay. Do you know, have you heard about componendo dividendo?
No, sir.
No, see, there is a concept. See, this is, suppose you have A by B. Oh, wait. Like, see, you have 5 by 2. Can I write this 5 by 2 as 10 by 4? Yes. Do one thing. Componendo says that if you add the lower one, the bottom one, denominator to numerator. Then do the same thing over here as well, right side as well. 10 plus 4 by 4. The C. Again, you will get the same thing. 14 by 4. Right? So if it is like A by B equal to C by D, then componendo says that you can apply A plus B by B equal to, if you have added B to A, then you have to add the same thing D to C as well. Same thing. B means it is simply like A plus B, A by B plus 1. You are adding simply plus 1 to both the sides. This is the componendo, right? First write this componendo. I'll tell you dividendo and then mixture of that.
Yeah, good.
Written, Ayushi and Parthiv.
Yes, sir.
Okay. Ayushi.
No, sir, 1 minute.
अरे ठीक है करो
Yes, sir.
now dividendo. Dividendo is suppose you have A by B equal to C by D. You can simply do -1 -1. So this is A minus B by B equal to C minus D by D. So you have subtracted B here, denominator. So you have to do the same thing on right side as well. And componendo and dividendo is A by B equal to C by D. Suppose you want to add B, you want to add denominator to numerator. You can do both way. So A plus B you did here. So you do C plus D here. And you do A minus B here. Then you have to do C minus D here. So whatever you want to do on the left hand side, you have to do the same thing on right hand side. You just have to keep the order same. This is what component or dividend.
Yes, sir.
Now see, I did the same thing over here. What I did was I added the numerator to denominator. I can see that if I add sin square A to this thing, sin square A will get cancelled and we'll have 1 only. Let me erase this part. Noted now?
Yes, sir.
See here. Now what I'll do is I'll just put sin square A here. This sin square that we got, I'll put over here. So this is 3 minus 4. Sin square is what? 1 by 4 k minus 3 upon k minus 1. This cancel. So this is 3 minus k minus 3 upon k minus 1. So this is 3k minus 3 minus k plus 3 upon k minus 1. Minus 3 plus 3 gone. 3k minus k. That is 2k upon k minus 1. Matched, right?
Done, sir.
Done, Aisha madam. Parthiv sir.
Yes, sir.
ठीक है. अब देखो, you have to prove the second part. You have to prove second part. This thing. How do you prove? So tell me, from here we got something, na? Tan square A, na? We got something. Tan square A. What was that? Can you please tell?
K minus 3 by 3k minus 1.
K minus
3.
on.
3k minus 1.
Right. See, we have to prove this thing, na? So see, tan square A. Square of anything always gives you positive value. So greater than or equal to 0. Now apply Webby curve method. Webby curve method, how we apply? So you have to equate every factor. So there is a term Webby curve method. Webby curve method. Do you know, Saina? IUC? Parthiv? No,
No,
na?
sir.
No,
So,
sir.
okay. I'll teach in detail in, I think, some. Okay, let me tell you something about this right now. And I'll make you practice more questions over there. See, this is Webby curve method is all about to find the sign of the expression. Question is like, we have this expression and we have to find the value of k for which this expression will be always greater than or equal to 0. We have to find the value of k for which this expression will be always greater than or equal to 0. Correct. So the steps is draw a number line, and if in the given expression, if there is if all the terms are in factor form, it's all right. If there is some quadratic or cubic equation, something like that, you have to factorize it first. And after factorizing it, make every factor, equate every factor to 0. So now I'll equate this factor k minus 3 to 0. We'll get 3. This factor 3k minus 1 equate it to 0. We'll get k equal to 1 by 3. Now you have got 3 intervals. One is to the right of k, one is to the left of 1 by 3, and other is in between 1 by 3 and 3. So you have 3 intervals. You can select randomly any interval. Suppose now I take this rightmost interval. So any number in this interval, you can pick any number that is greater than 3. You can pick 4, you can pick 5, any number, pick 4. Then in this expression, you have to put in this expression, whatever value you pick, put here. So suppose now I take k equal to 4. Put here 4 minus 3 upon 3 into 4 minus 1. You can see 1 upon 11. We are not bothered about the value. We are just concerned about the sign of the value. So this value is positive. So for any value in this interval, you get positive value. It means that for every value in this interval, the value will always be positive. So the sign of this interval to the right to the value k equal to 3. So for this interval, the value of the expression will always be positive. And now just alternate plus minus plus. You don't need to check it again. So this is called the Webby curve method or sign scheme method. Now this sign is for sign of the expression. It means that we have this expression positive if k is more than 3 or k is less than 1 by 3. Then only we can get this expression as negative. But if you take any value between 1 by 3 and 3, like 2, take 2, put here 2 minus 3, negative. 3 into 2, 6 minus 1, positive. So negative by positive, negative. So for this expression to be positive, k will have to be either less than 1 by 3 or k will have to be more than 3. This is what we wanted to prove. Understood? This is called Webby curve method. एक पढ़ा है बाद में. Done, everyone.
Yes,
Done.
sir.
Okay, next question. This is a very good question. Shaina, do you have Sankey's book, na? You have Sankey's book, na?
So I've ordered it. It's only coming on Sunday.
Okay, fine. Okay, fine. This one. Shaina, what is the name of your coaching in Bangalore? It is coaching or it's a school?
School, sir.
Okay, okay, okay,
School with an integrated course. So I'm doing
okay,
it.
okay, okay. I'll give 5 minutes for this question. This is very easy, but not that easy, not that difficult. Try this. Do you understand how to proceed? Let me tell you. I see? No idea or some idea?
Can you give 2 minutes?
Sir, half angle formula?
And no, that formula will not work. Shana, you need 2 minutes. Okay, try. No, there is no formula will work here. I guess. This is very simple, very simple.
So I'm just checking, like, will the angles be pi by 4, 3 pi by 4, and so on?
No, not so on. Tell me two more. Yeah, it would be like that only. But tell me two more.
And then there'll be 9 pi by 4, and then 11 pi by 4.
Why it is so? Why it is? Oh, very good. Yes, yes, fine. Yes, you got it.
Okay.
But you are taking like a value as 1 by root 2 now. You have taken one particular value now. That's why you're getting pi by 4 now. So just make it general. See how it will work. See, there are four angles. See, four angles, alpha, beta, gamma, and delta. And sign of all angles are same. And it is saying that alpha, beta, gamma, delta will follow this order and both will lie between 0 to 3 pi. Now you can see one thing. Suppose for this angle, whatever value of sine you get here, you get the same thing in second quadrant as well. See, like, sine pi by 4. Sine pi by 4 is how much? 1 by root 2. And suppose in second quadrant, if you see, it is like pi minus pi by 4. So that is sine 3 pi by 4. Again, you get same thing, 1 by root 2, because sine is always positive in first quadrant and second quadrant. Right? So if this is theta, so this angle would be what? Pi minus theta. Again, just rotate it by this angle. Or let me take angle as like theta, pi minus theta. First quadrant, second quadrant, and then again, and in third and fourth, sine will be negative. So it won't be same because the value of all the angles, sine of all the angles is same, k. So the next angle should be 2 pi plus theta. Theta, pi minus theta, and then rotate to come to first quadrant again. 2 pi plus theta. And then 3 pi minus theta. See, suppose this is 30 degree. So this angle should be pi minus theta, 150, sine 30 and sine 150. Both has same value, half. And now rotate by 230. Sorry, 360, 2 pi. So you will from here to here, you will again come to this place only. So 2 pi plus 30. Again, you will get the same thing. Now because sine of theta is equal to sine of pi minus theta is equal to sine of 2 pi plus theta is equal to sine of 3 pi minus theta. See, this is 0, this is pi. So one complete round, this is also 2 pi. So this theta, suppose this is theta, in second quadrant, sine pi minus theta, sine 180 minus theta, again sine theta, sine 2 pi plus theta. So 2 pi plus, so 2 pi plus, again it will come in first quadrant, sine 2 pi plus theta is always plus sine theta. And sine 3 pi minus theta, see, 2 pi and then one more pi, 3 pi or minus theta. So this angle falls in second quadrant, and in second quadrant sine is positive. And this is integral multiple of pi, so sine will remain sine. So all of these will have the same value. Understood or not? So
Yes,
we
sir.
have so these four angles. Now you can take any value. See, alpha is the least one, delta would be the greatest one, right? Suppose this is your alpha, this is your beta, this is your gamma, this is your delta. Now we are done. Put this value in there, in this expression. Sine alpha by 2. Alpha is theta. So this is theta by 2 plus 3 sine beta by 2. Beta is pi minus theta by 2. So this is pi by 2 minus theta by 2 plus 2 sine gamma by 2. Gamma is this 2 pi by 2. Pi plus theta by 2 plus sine delta by 2. So this is 3 by 2 minus theta by 2. Now you can see one thing. Theta by 2 is theta by 2. Let it be like that only. Now sine pi by 2 minus theta. What is it? Sine pi by 2. Sine 90 minus theta. Cos theta, no? So this is plus cos theta by 2. Now sine 180 plus pi plus. Pi plus means it will fall into third quadrant. In third quadrant, only tan and cot is positive, are positive. So sine will be negative. So this is minus 2 sine theta by 2. Sine 3 pi by 2 minus theta. 0 pi by 2 pi 3 pi by 2. 3 pi by 2 minus. So again, this angle will fall in second quadrant, third quadrant. Sine will be again negative. So minus, but this time, this is odd multiple of pi by 2. So odd multiple of pi by 2, this is odd multiple of pi by 2, sine will change to cos. So this is cos theta by 2. Now you can see 4 sine theta by 2 minus 2 sine theta by 2. 2 sine theta by 2, 3 cos theta by 2 minus cos theta by 2 plus again 2 cos theta by 2. Take 2 common. Sine theta by 2 plus cos theta by 2. Now you can see one thing. Now, okay, do one. Okay, first note it down, then I'll tell you. Getting my point, na? If you have any doubt, let me know. So whatever suppose whatever I taught you in this class, na, revise it before next class, and if you have any doubt, na, you can ask me in the next class.
Sir, done.
Yes, sir.
Parthiv also done?
Yes, sir.
Okay, अब यहाँ पे देखो. No, not देखो. See here. See, you have this thing, na, and you can write this as 2 into square root of sine theta by 2 plus cos theta by 2 ka whole square, right? So I can write this x as under root x squared, na? Correct, na? So under root x square is similar to x, na? Now,
Why
2
did you
into
write How can you write it as that, sir? Root of sine theta by 2 plus cos theta by 2 square.
See, you have suppose sine theta. So I can write this as I'll square it and then take a square root as well. Balance, na?
No, not that, sir. Okay, got it. Yeah.
Got it? Na? Now I'll see. I'll do one thing. A plus B to the power 2. A plus B whole square. That is A square plus 2AB plus B square. See here. This is identity. Sine square theta plus cos square theta. Angles are same. So this will be 1 plus 2 sine theta into cos theta. This will give you sine 2 theta. So 2 into theta by 2. Theta and your theta is what? Alpha, na? So sine alpha is k. So sine theta is k. So this is 2 into under root 1 plus I'll put theta equal to alpha. And we have sine alpha as k. So 2 into under root 1 plus k. That is answer D. This was a good question. Tomorrow at the same time, we'll have chemistry. And sir will start economic structure. In case sir will be busy, then I'll take class of physics.
Okay, sir.
See you tomorrow then.
Okay, sir.
Bye bye.
Thank you, sir. Bye, sir.
Bye bye.
Thank you so much, sir.
Thank you.